Hi, this is Ms. White, and our second solutions video is all about water and its very unique properties. When compared to all other compounds we can imagine, water indeed has very unique physical properties, and understanding this helps us understand water's behavior. Some of water's very unique properties are high boiling, melting, freezing point, liquid at room temperature, high heat of vaporization, specific heat, surface tension, the solid density, so ice, is smaller than the liquid density. This is the other way around for most substances. And it is also a great solvent for ionic substances, polar molecules, and gases. Let's look back at water's Lewis structure. Water has a tetrahedral electron pair geometry because it has 1, 2, 3, 4 electron domains. The central oxygen atom has 2 lone pairs of electrons. So this gives the water molecule its bent molecular shape because the lone pairs actually reduce the bond angle because they repel more. Water is a very polar molecule. In other words, it has 2 polar bonds like this, and our oxygen being more electronegative than hydrogen, the oxygen side of the molecule has a partial negative charge, and the hydrogen side of the molecule has a partial positive charge. So in water, the negative oxygen side of the molecule is attracted to the positive hydrogen side of the molecule and vice versa, and this forms really strong hydrogen bonds between water molecules. This is the intermolecular force that is present between water molecules. Also, hydrogen atoms being very small, they are able to occupy small spaces, and this makes that intermolecular force between water molecules even stronger. So we can see the hydrogen bonding between water molecules in this picture. We have the negative oxygen side of the water molecule being attracted to the positive hydrogen side of the water molecule in those hydrogen bonds. This strong hydrogen bonding helps explain all the following properties of water that we discussed earlier. Let's take a look at these properties in a little more detail. Water has a high specific heat capacity, which is defined as the amount of heat needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. It takes a lot of heat to increase the temperature of liquid water because some of the heat must be used to break the hydrogen bonds between the water molecules. So hydrogen bonding again. Water also has a high heat of vaporization. This one is the amount of energy needed to change 1 gram of a liquid substance to a gas at constant temperature. Just as it takes a lot of heat to increase the temperature of liquid water, it also takes an unusual amount of heat to vaporize a given amount of water because hydrogen bonds must be broken in order for the molecules to fly off as a gas. So hydrogen bonding again explains it. Let's look at surface tension. Water molecules' affinity for one another through hydrogen bonding is called cohesion. The water molecules cannot form hydrogen bonds with air, so the water molecules on the surface are not hydrogen bonded evenly. They are exposed to air on one side, and they will have fewer neighboring water molecules, so they will form stronger hydrogen bonds with the neighbors they do have, and this results in high surface tension. What that does is it causes water to form spherical droplets, and it allows water to support small objects such as a scrap of paper, a paper clip, a needle, and if they are placed carefully on top of the water, they will float. It also allows small insects to walk on water. We said that solid state of water, that is ice, is less dense than the liquid state of water. So if we look at the table, we have ice at a density of 0.9167. As the temperature gets to 4 degrees Celsius, we have liquid water, and its density rises to 1 gram per milliliter, so a higher density. Let's see why. The lower density of water in its solid form, that is ice, is because of the way that the hydrogen bonds are oriented as water freezes. The water molecules are pushed further apart than they are in liquid water, so water expands when it freezes. At 0 degrees Celsius, when water starts freezing, the hydrogen bonds between the molecules stabilize naturally in a crystal shape, and it actually forms a 3D shape like a honeycomb. This shape has a lot more empty space than water in the liquid phase. So that is why the density of ice is lower than the density of liquid water. Finally, let's look at water as a solvent. Water is known as the universal solvent because it easily dissolves polar molecules, ionic compounds, and gases more than any other known liquid. Because of this, pure water is really not found in nature. An uncapped distilled water bottle, distilled water is pure water, will not stay distilled very long because it will start dissolving substances from the air. So due to their polarity, water molecules are attracted to other polar molecules and to ions. Remember, the oxygen side of a water molecule has a slight negative charge and the hydrogens are partially positive. So here we see a water molecule dissolving ammonia. We have the positive hydrogen side being attracted to the negative nitrogen on ammonia, and the negative oxygen side of water being attracted to the positive hydrogen side of the ammonia molecules. With water dissolving an ionic compound like sodium chloride, the positive sodium ions are attracted to the negative oxygen side, and the negative chloride ions will be attracted to the positive hydrogen side of the molecule. Life as we understand it really depends on water being a good solvent, because at the cellular level, all of our biological processes will take place in an aqueous medium. This concludes Solutions Video 2. You should have taken high quality notes, rewatch the video as you need, and come to class with your questions.